Hello students, welcome back to my channel. Let us continue learning database concepts. In today's session, we will be talking about basic rules for relational data model. Now this relational data model, we have 13 rules which has been proposed by Codd. So Codd this is the person, E.F. Codd. He is the one who has proposed the relational data model. If you remember, we had studied the different data models. In that we have seen hierarchical, network as well as relational. The relational was proposed by E.F. Codd. Now basically he has given us 13 rules and they are also called as Codd's 12 rules. Basically because there are totally 13 rules and they start from 0 and they will end up till 12. So 0 to 12, that is why it is called as Codd's 13 rules. Now these are the rules proposed in a way that this has to be satisfied by any database. So E.F. Codd was a computer scientist who invented relational model for database management. Based on relational model, relational database was created. Codd proposed 13 rules, popularly known as Codd's 12 rules, to test DBMS concept against his relational model. Okay, so they start from 0, go up till 12. That is why there are totally 13, but they are called as Codd's 12 rules. Codd's rule actually define what quality a DBMS requires in order to become a relational database management system, that is RDBMS. Till now, there is hardly any commercial product that follows all the 13 Codd's rule. Even Oracle follows only 8.5 out of 13. The Codd's 12 rules we will be seeing in today's session. So as we know that the 13 rules whatever we are going to learn, it is practically impossible to follow all of them. But in the commercial, okay, in real world, the Oracle which we use can only follow 8.5. So all the 13 it is not possible. But according to Codd, he says that the database whichever follows all these is the one which can be called as RDBMS or relational database model. Now let us see the rules one by one. The very first rule is rule 0. This rule states that for a system to qualify as RDBMS, it must be able to manage database entirely through the relational capabilities. Now, what is the meaning of relational capabilities? So, we know that in a relational model, so we have studied network model, we studied hierarchical model. In hierarchical model, we had records which were stored in this way, that is in a tree-like structure. Then we know that we have studied network model where all the records were connected to each other. And then the third one is nothing but our relational model, where the tables are related to each other in the form of columns. The columns were related. So these relational capabilities must be there at any given point in the database. Then only it can be called as relational database model. That is what our rule 0 says. So relational capabilities is a must when it comes to the RDBMS. The rule 1 says information rule. So what is this information rule? All information including metadata. Now what is this metadata? Metadata is nothing but data about the data. For example, if there is a student data in the database, all the details about the student is nothing but the metadata. Okay, has to be represented as a stored data in the cells of the tables. The rows and columns have to be strictly unordered, which means all the data should be maintained in a tabular form with the column as well as the rows. So if I have a column and any data, whatever the data is there has to be in a row and column form, and there need not be any order. Okay, so data can be stored in any order, that is your column need not be in any order, your row need not be in any order, but data has to be stored in a tabular format. That is the rule 1, which is your information rule. Rule 2 says guaranteed access. Now what is this guaranteed access? We have say in the rule 1 says that all the data should be stored in the table. Now it should be able to access. We should be able to access any data with the help of table name, primary key and attribute. Okay, so what is this primary key? So for example, if I have a table okay, and I'm storing the student details in this, then usually student will have something called as his name. We will have name, and we will have his other details like register number and all those things. So what is a primary key? A primary key should be able to uniquely identify each row. Okay, so what can be primary key here? Now name can be, two students can have two same names, isn't it? If for example Naveen and Naveen, there can be two students in a section with the same name. Sometimes even their surnames match. So in that case I cannot take name. What about mobile number? Okay, mobile number, a student might have a mobile number, another student might not have a mobile number. Then what else is a thing which every student will have, as well as it will be unique? So can I take register number, isn't it? So register number every student will have and it will be unique. So then I can take register number as a primary key. So basically a primary key is the one which can uniquely identify each data in a row. For example, if I want to access a data of a student whose register number is 101, in such case, how will I access the data? First, I will use the table name, which is student. Then I will use the primary key, which is the register number, and then I can access that particular attribute. For example, if attribute is name. Okay, so table name here is student, primary key is my register number, and attribute is any attribute. Attribute will be column, any column which I want to access. Okay, so for example, if it is 101 is the register number, so I'll go to the student table, then the primary key is register number, and 101, that respective data I am able to pick. For example, if it is a name I want to access, column name, then I can do that. Now at any given point, we should not be able to directly access the data without using the table name and primary key. We should not be able to access the data. That is what guaranteed access means. Now let us go through the next rule, that is your systematic treatment of null. Now what is this null value? First we should know, before we understand what is the treatment of null, what is the meaning of null. Now remember students, null is not same as 0 or not having any value. These are the three different things. So when I say null, null can be because of many reasons. A null in a database can happen because of missing data, not applicable, or no value. What is the meaning of that? What is missing data? For example, consider a table where we are storing the student data and we want to store the mobile numbers of a student. Okay, now suppose the student has a mobile number and he has not filled that detail in the form, then that will become a missing data. Similarly, what is not applicable? Suppose a student is not having a mobile phone, that is not applicable to that particular student. Okay, similarly, no value. What is the meaning of no value? No value also, for example, a student is having a landline but not a mobile number, is also no value. So in such situations we can fill the null value. That is why systematic treatment of null. Okay, it should be handled consistently, and also you should remember that primary key cannot be null. So expression of null must give null. And also you can see this example where suppose a salary column, so we cannot have a value for a student, isn't it? For a student, a salary column becomes not applicable or no value. So that is also another form of null. So remember, null, 0 and not having any value, leaving the database empty, are entirely different things. So we should treat the null in a systematic way. Okay, so that becomes your rule 3. Now let us go for rule 4, which is active online catalog. So what do you mean by catalog? A catalog is nothing but a data. For example, we have a database. So we will have a detailed information about all the data which is being stored in the database. So database dictionary must have description of database, catalog to be governed by same rule as rest of the database. The same query language to be used on catalog as on application database. So what is the meaning of that? So whatever the rule or query language you are applying on the database, same thing will be applicable on the catalog also. So catalog basically holds all the information about the database, and the set of rule will be applicable same. Next is the next fifth rule is powerful language. Now what is this? So must provide all manners of access to data. So we should have a language which should provide all the manners of access to data. For example, in database we are storing the data. I want to access, isn't it? I want to access that stored data using a language. For example, SQL. I want to store the data, retrieve the data, everything I can do with the help of a language. In an SQL, when you are using in your practical, basically SQL is a language which you are using in order to store the data as well as access the data. So database will have all the data. How will you communicate with the database? Is using a language. Okay, so we will write different kinds of queries and we will be able to, for example, select star from student table. When you are saying, it is nothing but it is a language you are using by which you will be able to access the data. I hope these rules are clear. Let's move on to the next one. So rule 6 says view updation rule. So what is this? All view that are theoretically updated should be updatable by the system. So theoretically, if you have certain rule, then you should be able to update practically in the system as well. That is what the rule 6 view updation rule says. It has to be updated in the database also. So that is what this rule 6 means. Rule 7 says relational level operation. So there must be insert, delete, update operations at each level of relations. Okay, also set operations like union, intersection and minus. So what is this? So we will have n number of tables and these tables are connected with the help of a primary key, and we will also have a foreign key because of which they will be connected. So we can have hundreds and thousands of tables in a relational database system. So whenever we have, even if we have whatever the level of relationship, we should be able to insert, delete and update operation. Similarly, we should be able to perform set operations like union, intersection and minus. Union is adding two tables, intersection is taking the common columns, and minus is I'm subtracting the values of the first table from the second table. So these operations also I should be able to perform at any level in a relational database. Okay, so the next rule 8 says that physical data independence. So what is this? So this physical data independence and logical data independence we have studied already when we learned the 3 schema architecture. So physical storage of the data should not matter to the system. If say some file supporting table were renamed or moved from one disk to another, it should not affect the application. So what does this mean? Basically, we know that database has all the data stored in it, and then we have a logical level, and then we have a view level where the user sits, isn't it? So whatever the changes I'm doing in my database, whether I'm storing it in a different disk or whether I'm changing the file name, it should not affect the user. Whatever the data I'm storing, whatever the kind of data I'm storing, any changes I'm doing, it should not affect the user. That is nothing but physical data independence. Similarly, logical data independence is change in the logical structure or the table structure of the database. The user view of the data should not change. Okay, what is the logical structure? Now this is where the logical structure is, how the table is going to be, what are the details we are going to store, is everything is going to be there in the middle structure. So any changes I am doing, it should not affect the user. That is what the logical data independence mean. Okay, so these are the two physical and logical data independence which we have already studied in our previous sessions. Now let us move on to the last rules, 3 rules. The first one is integrity independence. What is this integrity independence? The database should be able to enforce its own integrity rather than using another programs. Okay, key and check constraints, triggers, etc. should be stored in the data dictionary. This also makes RDBMS independent of the front end. So database has all the data in it. So whenever we are storing the data, we should not have an external program to check whether everything is in proper way. We have keys like primary key, foreign key, then we have constraint, null constraints, check constraints, such many constraints we have. Also we have triggers which will help us in order to make sure that integrity is there in the database itself. We need not know or need any external program in order to achieve it. That is what the rule 10 says. Now rule 11 says distribution independence. Now a database should work properly regardless of its distribution across a network. Okay, for example, Google. Now Google's database might be available in USA, it might be available in India. Okay, one database is stored in USA, one is in India, another may be in somewhere in Japan. So whenever we are Googling, it should not worry me or bother me that wherever the database is, physically wherever it is available, I should be able to access it without any problem. So that is what distribution independence means. Wherever it is stored across the network, it should not bother the user. It should give the same kind of a performance. That is when it will become a RDBMS. Now the last rule, which is rule 12, non-subversion rule. It says that if low-level access is allowed to a system, it should not be able to subvert or bypass integrity rule to change data. Now what is the meaning of that? If there is a low-level access, means if it is an end user who is accessing it, then he should not be able to modify the data of the database. There has to be a certain kind of a restriction. Now how do we achieve this? This can be achieved by some sort of looking or encryption. So we can encrypt the data in order to have a non-subversion rule satisfied in a database. So these are the 12 rules proposed by EF Codd. Now let us do a quick recap. So according to EF Codd, a database is RDBMS only when they satisfy all these 12 rules, which are nothing but 0 to 12. So totally there are 13 rules. Let us quickly recap. So first rule says foundation rule, then we have information rule, guaranteed access rule, systematic treatment of null values, active online catalog, powerful and well-structured language, view updation rule, relational level operation, physical data independence, logical data independence, integrity independence, distribution independence, non-subversion rule. So these are the total 13 rules of EF Codd. I hope this session has been useful to you students. Keep learning and keep watching. Thank you for watching.